Hi there, my name is Natik and I'm going to be explaining to you our final year project, Solar Thermal Air Conditioner. So, what is a solar AC? A solar AC is an AC that uses the solar energy to operate. Well, that's good, but we do not use a photovoltaic system. We use a solar thermal system. The sunlight is used for the purpose of dehumidification. Absorption chillers work in a very similar way. If we look at the pictures on the right, top right is a coil that is placed inside a concentrator where heat is provided. The concentrator is on the left, it's a parabolic dish, and on the bottom we have a few of our components. Moving forward, how does it work? So you might wonder how you can use heat to generate cool air, and I will be explaining that right now. So if you look at the diagram, okay, you can see that there is a cycle over here and a separate component where sensible cooling occurs. Other than the sensible cooling unit, we have a cycle which basically flows from the dehumidifier to the heat exchanger, from the heat exchanger to the heat source where we'll be using a solar concentrator. Then from the solar concentrator, it moves into the regenerator, back into the heat exchanger, and it is cooled further in the desiccant cooler and moved back into the dehumidifier. So this cycle basically is used for the dehumidification. The heat that is added by using concentrators. Concentrators act like magnifying glasses in a similar way, yeah. Although they look different, they work in a very similar way. Moving on, so what would we heat exactly, right? So why do we need to heat and what do we heat? The desiccant. The desiccant is a hygroscopic material. Basically, it is a material that aggressively absorbs water vapor. So we use it to absorb the moisture from the room, but it will eventually get saturated and becomes unusable unless it is regenerated. So this glycol will become dilute as water vapor is added to it, and we need to remove the water vapor eventually so that we can reuse it to dehumidify the room further. For our purposes, we are using triethylene glycol. So this cools the room? No, it does not. The cooling of the air entering the room is actually done by an indirect evaporative cooler. You remember the cycle which had the first unit called a sensible cooling? Well, this is that part. The indirect evaporative cooler basically is a system which has copper pipes that are wrapped with cloth from the outside. Now this cloth is kept damp with cool water. The water absorbs the heat of the air through the pipe and then evaporates, taking away the heat. This produces a certain temperature drop in the air that is entering the room. So the indirect evaporative cooler actually will reduce up to 40% of the cooling load of the entire system, which is very important. Wouldn't we need to cool the water? So yeah, I did mention that we would be using cool water, and yes, we would need to cool the water. How are we going to achieve that? Is by the NSR. The NSR is a night sky reservoir. We use the technique called as night sky cooling to cool the water. What is it? It is basically we cool the water during night time, and that is done by radiating the heat into the atmosphere. Now, most of the radiation that is emitted from the earth does not escape the earth's atmosphere. Only the ones that lie between 8 and 15 microns of wavelength escape the atmosphere. And the Iraqi civilization figured it out how to make ice without electricity, and we use their idea in a slightly modified way. Why haven't you heard of this before? Well, research has been done on this previously, but due to the availability of and the compactness of the current technology, that is the vapor compression system, it is preferred over the system that we are building. Our system is currently operational in certain areas where dehumidification is required in pharmaceuticals, etc. Although it is important for us to right now bring it into our residential and commercial lives for actual cooling. Up until the past few years, global energy demand and climate change were a topic neglected, but right now, global warming has reduced our resources, and we need to come up with new ideas, better ideas to fix it. So we have built an AC which can do that. Now you would like to know if it actually works, right? Well, every component in this setup has been tested separately. And the IEC, that is the indirect evaporative cooler, as you can see, when the ambient temperature was around 30 degrees Celsius, the drop in temperature were recorded as 21 in the winter and 26 in the summer. Now, it might confuse you as to why it has such a huge difference. Well, the reason it has a difference because of winter and summer is that the ambient relative humidity in winter is quite low, so the evaporation takes place at a faster rate. The dehumidifier dropped the relative humidity from 77% to 65% in a span of about 2 to 3 seconds, which is very good. Concentrator. The concentrator, when the ambient temperature on the roof was around 38 degrees, the stagnant desiccant temperature was easily reached 110 degrees and 60 degrees when it was flowing. And the NSR, the night sky reservoir, gave us a temperature of 23 degrees when the ambient temperature was 25. So why wouldn't you just buy a normal AC? Well, you could buy a normal AC and it would be better at cooling. Although an AC coupled with this system will not only reduce the operating cost by at least half, it will also be environmentally friendly. Standalone AC systems based on solar can easily become commercial in the future if further work is done. So how does it look? Well, here are some pictures. On the left you can see this is the dehumidifier, and on the right side is the indirect evaporative cooler. On the left we have the parabolic solar concentrator. On the right we built a makeshift heat exchanger. On the left we have a desiccant cooler, and this is the control system on the right, where we measure the temperatures from 5 different sensors. Here's a video of the AC.